Hello guys, welcome to Infinite Insight Geometry, lesson 1.6. Counterexamples. Alright, let's begin. So, a counterexample is a singular example that proves a conditional statement false. For conditional statements, all instances of the statement need to be true for the conditional statement to be true. That means that every single instance of the statement, meaning that just one false counterexample is enough to prove a conditional statement false. Alright, here we have an example. If an animal is a bird, then it can fly. To find a counterexample, we need to find an instance where the hypothesis is true, but the conclusion is false. In this example, we need to find a bird, that's the hypothesis. The hypothesis is true, so the animal is a bird that cannot fly. The conclusion is false. So we negate it can fly to it cannot fly. So we're trying to find a bird that cannot fly to prove this conditional statement false. And if you want to think about it for a bit, go ahead, but the counterexamples for this, well, there are a lot. There are chickens, penguins, flamingos. There are lots of others that I won't mention right now, but the key thing here to note is that just one counterexample is enough to prove it false. For example, all we needed is chickens. Chickens are a bird that cannot fly, meaning that this conditional statement is false. So for geometric and mathematical counterexamples, well, usually in the middle, we're going to find some things that usually fit the conditional statement. So to find counterexamples, we need to find unusual cases, extreme cases. Some examples are shown here, like what happens at 0, what happens at the smallest, the largest number, what is the simplest and most complex case, what happens in special geometric figures like circles or spheres, what happens then. So here's an example of a mathematical conditional statement. The product of two numbers is always greater than either number. So basically, we multiply two numbers and the product is greater than each of its factors. So 4 times 5 is 20. 5 times 7 is 35. 20 is greater than 5 and 4, obviously, and 35 is greater than 5 or 7. But then we're trying to find some counterexamples so we can prove this statement false. So how do we do that? Well, all we need is to look at extremes. Like, for example, 1 times 6 is 6. 6 is not greater than 6. 6 is equal to 6. And we can even see that in the next example. 0 times 3 is 0. 0 is obviously less than 3, meaning that the counterexample proves that this conditional statement is false. And we can even see here, two decimal numbers equals a smaller decimal number. 0.5 times 0.5 equals 0.25, which is smaller than either 0.5 that we started with and we multiplied together, meaning that this conditional statement is false. But we provided 3 counterexamples here. But the key thing here to know is that only one counterexample is needed to prove this conditional statement false. We could just end with 1 times 6 is 6. That's a counterexample proving this false. We don't need a lot of counterexamples. We just need one. And that'll be all for today's lesson. If you liked the video, please like, subscribe, and comment down below. If you have any questions, I will put my Gmail down below in the description, and I will see you all next time.